Now, senior, let's take those factors one after the other. Let's take those factors one after the other. Factors affecting the discharge. Factors affecting the discharge of ions in electrolysis. Factors affecting the discharge of ions in electrolysis. In our last video, we listed those factors, but now this time let's try and explain each one. First one was preferential discharge of ions. What do I say? Preferential discharge of ions. Or let's call this one. Okay, first one, not preferential discharge. Preferential discharge is a general, a general definition for all the factors. But the first factor we are going to look at, which affects the discharge of ions in electrolysis, is position of ion in the electrochemical series. We can call it electrochemical series or call it activity series. Position of ion in the electrochemical series. Now, the electrochemical series, that's the first definition we should write here. The electrochemical series, I'll be moving upwards fast, so please write fast. Position of ion in the electrochemical series. Let's go. The electrochemical series is the least it's just a list, nothing technical about series. The electrochemical series is the list of cations and anions. Is the list of what? Cations and anions arranged in order of reactivity. The electrochemical series is the list of cations and anions arranged in order of their reactivity. Arranged in order of their what? Reactivity. In order of their reactivity. You understand? Reactivity means how strongly electropositive. Reactivity means how strongly electropositive or electronegative. And reactive an ion is. Now, that reactivity series also has two sides. You understand? There are two parts in a reactivity series. Let's put it that way. There are two types of, or let's say types. There are two types of activity series. There are two types of activity series, namely the cation series, activity series, and two, the what? Anion activity series. It's just a list. You must memorize the list so that every time you come across two ions approaching an electrode, you know which one should be discharged preferentially. Cation activity series. Let's do cations first. Cations activity series. Cation activity series. There's an acronym for remembering it. That acronym is LIPO. Take it after me. Liposocama Z. Liposocama Z. hyco. Liposocama alzifetile hyco mesiplago. We like to write this hydrogen in a different color because the position of hydrogen has a significance. I'll be explaining that soon. Liposocama alzifetile hyco mesiplago. Mesi what? Plago. Liposocama alzifetile hyco mesiplago. So let's now try to write their ions and make meaning of each of these acronyms. So one after the other, let's go. Li is for Li plus, lithium. Po is for potassium, K plus. After K plus comes Na plus. After Na plus is Ca2 plus. Now after Ca2 plus is what? Excuse me, Mg2 plus, Al3 plus, Zn2 plus, Fe2 plus. Tin is Sn plus. Tin is Sn plus. Lead, Pb2 plus. Hydrogen, H plus. Let me try and change the color of hydrogen. Hydrogen, H plus. Excuse me. Let's use this. Hydrogen, H plus. Then what? Okay, let me be consistent with that color of hydrogen. Hydrogen, H plus. Let's go. Co, Cu2 plus. That's copper. Mercury, Hg plus. You look up your, what's it called? If there's anyone. Essence, silver, Ag plus. Those ions I'm not writing well. Platinum, Pt plus. And gold, Au plus. Now, according to this series, reactivity of the ions decreases from top to bottom. Reactivity decreases from top to bottom. So the ions are decreasingly less reactive as you go down this series. Never mind the crookedness of my line. You make yours straight with your ruler. So reactivity decreases as you go down this series. Let me write that on the list so that you can see it. Reactivity decreases. Reactivity decreases downwards as you go down the series. So that's the cation reactivity series. Let's now do the anion activity series. We call it activity series or reactivity series or electrochemical series. Let's do it for anions too. Those of anions are not very much, just a few. Fluoride, sulfate, nitrate, NO3 minus, fluoride, sulfate, nitrate, chloride, bromide, iodide, hydroxide. I think they are just 8 for our level. Okay, 7. Fluoride, sulfate, nitrate, chloride, bromide, iodide, hydroxide. So this is the order of reactivity of anions. This is the order of reactivity of anions. So that means as you come down from top to bottom, the reactivity of the anions also decreases. So as you come down from top to bottom, reactivity also decreases. Let's label that too. Reactivity does what? Decreases. Reactivity decreases. As you come down from top to bottom, reactivity decreases. So now let me now show you the significance of this. I explained the electrolysis of of what? Of sodium chloride the other time. Let me quickly give you a significance of this. If you have an electrolyte that is such that the electrodes are connected, and what? The electrodes are connected to a DC source, and inside the electrolyte, inside the voltaic cell, the electrolytes you have, let's say for example the electrolyte you have, we'll go into more details here later, but let me just quickly show you the significance of the activity series. Let's say the electrolyte you have here is sodium, let's say the electrolyte is sodium chloride aqueous. Now sodium chloride aqueous will mean what? Sodium chloride dissolved in water. So it contains both sodium chloride solid dissolved in, you understand, H2O liquid. So at the end of the day, everything will mix up. The white crystalline sodium chloride solid will disappear, and you have NaCl aqueous. Now, when you have NaCl aqueous, there will be 4 ions present. The sodium chloride will dissociate into Na plus and Cl minus. The water will dissociate into H plus and what? OH minus. The water will dissociate into H plus and OH minus. So at the end of the day, you have 2 anions and 2 cations in the electrolysis. So you have Na plus and what? Cl minus, and you have what? H plus and what? OH minus. Now, since your cell has been connected to an external source of electricity, that means there will not be delocalized motion again. Anions will now drift towards the anode. This is the anode. This is the anode. This is the cathode. So anions will drift towards the anode. That means this will drift towards here. This one too will drift towards here. Cations will drift towards the cathode. Na plus will drift towards here. H plus too will drift towards the cathode. Can you see that? So that means at the surface of the cathode, let me now show you what happens at the surface of the cathode. Let's assume this is my cathode. Let's assume this is my, okay, let's do anode first. At the surface of the anode, let's assume this is my anode. 2 anions will approach this anode. Cl minus will approach it. OH minus 2 will what? Approach it. So at the surface of the anode, only one of these ions will be discharged. So to determine which one will be discharged, you call on your anion activity series. Between chloride ion and hydroxide ion, which one is more reactive? Those are the 2 anions. Between the 2 anions, which one is more reactive? So you will notice that the chloride ion is far up in the series, while the hydroxide ion is down. So this one will be more stable and will stay. Preferentially, hydroxide ion is the one that will be discharged because it is less reactive than what? Chloride ion. So what will happen is that at the anode, OH minus will be discharged like this. 4OH minus will lose electrons to give you water and what? Oxygen gas. Water liquid. Aqueous. So oxygen bubbles will be produced on the surface of the what? Anode, because hydroxide ion will be discharged. You understand? That's what we call preferential discharge of ions. You can see 2 ions get to the anode, but the less reactive one gets discharged. The less reactive one, which is the hydroxide, gets discharged, and this more reactive one stays. Let's look at what happens at the cathode. What happens at the cathode? Let's look at what happens at the cathode. This is the cathode. This is my cathode, and it is what? Negatively charged. 2 anions approach the cathode. 2 cations approach the cathode. H plus and what? Na plus. Can you see that? 2 cations, hydrogen and sodium ions, approach the cathode. One of them will be preferentially discharged. Let's go check our activity series. Which one is higher up in the series, hydrogen or sodium? Look at the position of sodium here. Sodium is right up here, but hydrogen is down here. Hydrogen is what? Down here. So that means sodium is much more reactive than hydrogen. Therefore, hydrogen will be what? Preferentially discharged in this case. And sodium will stay in the solution. So it is hydrogen that will be kicked out of the solution. That means the cathodic reaction in this electrolysis will be, what? H plus will gain electrons to form H. H plus will gain electrons to form H. And at the end of the day, 2H plus 2E minus will give you H2 gas. So bubbles of hydrogen gas will be seen formed on the surface of the cathode. You understand? That's how what's he called? Preferential discharge occurs. Let's now go to the next factor affecting the discharge of ions in the electrolysis. Let's go to the next factor. Next factor is number 2. Nature of electrodes. Nature of what? Electrodes. In some electrolysis, the nature of the anode, whether it is active or passive, determines how ions are discharged in the electrolysis. Determines how ions are discharged in the electrolysis. An active anode. An active anode gets oxidized. An active anode gets oxidized and enter into the electrolyte. An active anode gets oxidized and enter into the electrolyte as positive ions. While a passive anode does not get oxidized. You will see the essence of that when we take on some examples of electrolysis. Let's just go to the third one in order not to waste too much time. Third one is concentration of ions. Now, preferential discharge of ions in electrolysis is also affected by the concentration of ions in that electrolysis. For example, this affects only anions. The concentration of anions. The concentration of anions present in an electrolyte. The concentration of anions present in an electrolyte determines which of the anions gets discharged. For example, For example, in the electrolysis of dilute NaCl aqueous, in the electrolysis of dilute sodium chloride above, the hydroxide ion is not discharged. The hydroxide ion is not discharged when the hydroxide ion is not discharged when concentrated sodium chloride is used. The hydroxide ion is not discharged when conc NaCl is used. When conc NaCl aqueous is used. When conc NaCl aqueous is the electrolyte. So what happens in that case is that if your electrolysis was, if the electrolysis was conc NaCl, that here we said the electrolyte was dilute NaCl. Here the electrolyte was what? Dilute NaCl. But if you change this electrolyte to conc NaCl, a different thing happens at the anode. Let's take a look at that. Now, let's say these are my electrodes. Connected to a DC, and instead of having dilute NaCl, I now have what? Instead of having dilute NaCl, let's say my electrolyte is now concentrated sodium chloride solution in water. Now, the same thing will still happen. I will have anions. What will be the anions? Cl minus and what? OH minus will still be my anions. Then, what cations will I have? I will still have the cations H plus. Okay, let me put it in order. I will still have the cations Na plus and what? H plus. Now, these two ions are from sodium chloride. You understand? They are from sodium chloride. And these two are from what? Water. So, at the anode, this is my anode, this is my cathode. Anions drift towards the anode. So, in this solution, let's put it this way. Na plus will drift towards the cathode. It's a cation. H plus 2 will drift towards the what? Cathode. It's a cation. But anywhere chloride ions are in solution, they will drift towards the anode. Hydroxide ions too, anywhere they are in solution, they will also drift towards the anode. So cations will drift towards the cathode. Anions will what? Drift towards the what? Anode. So as you can see here, if it was dilute sodium chloride solution, because chloride ions are higher in the series than hydroxide ion, the hydroxide ion get preferentially discharged as oxygen and water. But in this case where we are using concentrated sodium chloride solution, in this case where the electrolyte is conc NaCl, when the ions get to the electrode, when the anions get to the anode, Cl minus will be discharged as chlorine gas like this. It will lose electron, get oxidized. One chloride ion will lose electron, get oxidized. Then put these two together, you get 2Cl minus 2E to give Cl2 gas. So this is how chlorine gas will be discharged at the anode instead of oxygen or hydroxide ion getting discharged as oxygen gas and water. So you will see greenish yellow bubbles. Let me use green. Okay, or this. You will see greenish yellow bubbles of chlorine on the surface of the anode due to the concentration of the chloride ions in solution. So those are the ways ions get discharged preferentially in electrolysis, depending on the conditions of the electrolysis and the concentration of the ions. I'll give you a classwork before we start in the next video, but this is all for now.